Viktor. I used to work at the Flutter team when I worked in Silicon Valley for Google. Now I'm the founder of Serverpod. Moved back home to Stockholm. I'm also the main organizer of the Full Stack Flutter conference, which we held early this year or in May with like 4,000 attendees. Today I'm going to talk about moving from the front end to the back end. So I know most of you are probably Flutter developers and may have not worked as much on the back end. So that poses a few different challenges, right? First, you need to figure out how to manage servers and databases. You need to learn new tools and maybe even languages, unless you use Serverpod, of course. Then there's a whole other set of performance bottlenecks on the server. In your Flutter app, you worry about having a constant frame rate, maybe not rebuilding your widget tree every frame, and making sure you can run all your animations and stuff like that. On the server side, you may work with huge amounts of data and have to pull information very fast, and unless you do that, it slows down everything, not just for a single user, but for like all the users of your app. Then you have the problem of deploying this to the cloud or hosting it yourselves, and maybe setting up DevOps with CI/CD chains and stuff like that. So today I wanted to tackle a few of those challenges and hopefully make you comfortable to take that step. First, I want to dive into a little bit of the basics of building a backend. And there are really two types of backends that we see today. You have the serverless backends like Firebase and Supabase, where you sort of access that mainly from your app. And then you have app servers, where you have a server that talks with a database. And typically, you use a relational database in that case. And most of these serverless frameworks use more of a document database. So we're going to dive in more on the app server side here and look at relational databases. And a relational database is basically a set of different tables. A table is very much like a spreadsheet in Excel, if you will, where every row is an object, if you will, and every column is a property of that object, like an integer or a string or even binary data or dates, or you can have many different types. But what makes relational databases so much powerful than the spreadsheets is that you can connect them. So maybe you have one user, but that user has placed many orders on your site. So that gives you a relation between the user and these orders that are paired with the user, and that is called a one-to-many relationship. Then you have the option to also search very big amounts of data using SQL queries. SQL is the standard query language, which is a little bit of a funny name because it's not so standardized at all. Like every single database has its own variant. But it also allows you to do indexes on these databases, which makes it very, very fast to perform different queries. Then you have the concept of modeling, creating models that are linked to the rows in your database. And that's used through something called object relation mapping, or an ORM. We're going to dive a little bit more into that too today. So in the simplest of backends, you probably have a database somewhere. Then you have an API server, and you have a client. So the client will talk with the API server, which then pulls data from the database and sends that back to your client. So this is a sort of a simplified example. But the API, you can even make an API, obviously, without the database. Maybe you pull the information from ChatGPT or something else. So there are a few things you need to keep in mind when you build your API server. First, you need a way to serialize data. And that's basically how you take your objects you have both in your database and in your server, and how you pack that together and send that to your client, or the client is basically the same as your app in this case. So that's called serialization. You basically pack it together into text. The most common way to do it is with JSON serialization, which I think most Flutter developers are somewhat familiar with. And you typically do it over HTTP. Then you have the concept of endpoints and endpoint methods. These are basically like web pages on your server, like methods that you can call to retrieve this data and pass data to. Next, you may have to worry about load balancing and scaling. If you have a lot of users, you may need to have many different servers. And then typically you put the load balancer in front of these servers. So the load balancer will sort of randomly send it to one of your servers that can serve that request. So a more realistic sort of infrastructure for your server may look something like this, where you have the client on one side, it talks to a load balancer, and you have a set of API servers, and they all talk to the same database. However, the most expensive operation you do, typically when you build a backend, is talking with your database. So you want to make as few queries to the database as is possible. And therefore, you most often want to use a cache. The cache can be either inside the API servers, or you can have a specific server, like Redis is a common choice for caching objects. So for instance, here I can have a news app. The first news page I want to say serve to every single user. They see the same first news page. Then I can pull all the data. Maybe that will be even hundreds of requests to the database to build that. It can be comments, there can be different news stories and links that you need to group together and send to the client. Then I can put that whole page in the cache and just pull it from there and save a whole bunch of database queries. And then I can invalidate the cache maybe every minute or every 15 minutes, depending on what sort of data you're storing. Next, I want to talk a little bit how we can do all this with Serverpod. And Serverpod is a backend written in Dart for the Flutter community. It's all open source and free, so you can get it basically on GitHub. We made it very easy to install. I'll show you in a second. We have today over 10,000 Serverpod developers out there, which we're very proud of, and like 1,000 apps built on Serverpod to date. Apart from generating the whole API for you, basically in Serverpod, I'm going to show this in a little bit. You create a method on your server, will analyze your server code and replicate that in the client. So calling that method on your server is just as easy as calling a method in your app. Then we added things like a great logging system with a visual log viewer. You can pinpoint exceptions and slow queries, for instance, very, very fast. We built in caching. So caching is something that often is an afterthought when you build your backend. When you realize the expense for a database start going up, it's really nice to be able to have that there, and that just fits into the ecosystem you're already working in. And then, of course, we built an ORM for Postgres, which is very complete. We have support for relations, we have support for database migrations. So we're going to have a little bit of a look at that further on. Then we support everything you typically need from a modern backend framework. You can upload files to S3, AWS, and Google Cloud. Even if you're developing locally, you can have it in your local database. You can authenticate with Google, Apple, social sign-ins, email. That just works. You can stream data if you want to do real-time communication, if you're building a game or a chat app. We have task scheduling. So say you have a user that signs up, and you want to remind them 1 week from now. You can make something in Serverpod called a future call. So you just say, call this method 1 week from now with these parameters, and Serverpod will just make that happen. Then we perform health checks on your server, so you can see that everything is up and running, like the CPU, memory usage, how the database is responding, stuff like that. You can even add your own services there. We made it very easy to deploy your server, which is also a big pain point. We made Terraform scripts, so that's basically a way to set up your infrastructure on both AWS and Google Cloud. And we are also building our own Serverpod cloud that will make it like seriously super simple. And that's in beta right now. So I give you a little demo at the end of how to do that. If you encounter errors in your server somewhere, we built a great logging tool that actually groups the logs together with a session that is a user call, for instance. And you can also turn on and off logging for different parts of your server. And that can be super useful. A common cause for your server to be slow, for instance, is that a database query is slow somewhere. So you can turn on logging just for slow queries. You can pinpoint that query, and it even comes with a stack trace. So with a single click, it'll take you back in the code. If you built any backend before and struggled with this, you know how painful this can be otherwise. So you have to download logs, run them through some specific program, and then you may find out which query it was, but you don't know where in the code it was called. So this is sort of a game changer in pinpointing those errors. Next, we're going to look at sort of more practical stuff on how you use Serverpod. So first, looking at installing it, which is super simple. You just do a dart pub global activate Serverpod CLI, and that's it. You need to have Flutter installed for this to work, but I guess as you're Flutter developers, you probably have. You may also...
Could I ask why?
Why you need Flutter?
Yes.
So the reason you need Flutter is basically, technically you don't need Flutter, but you need Dart. Yes. And Dart comes with Flutter. And then we also have, if you're building a Flutter app, we also have Flutter libraries. So we will set up a Flutter app for you. So I'm going to show that just in a little bit. Typically, you also want to have Docker installed. And we use Docker just to start a Postgres server, because that is otherwise somewhat tricky to install. And with Docker, it's just a one-liner. All right, and you can run the serverpod command just to check that everything works. Next, we're going to look at how we set up our project and what that looks like. And you do that with the serverpod create command. Here we do a new project called mypod. And basically, it will create a directory with 3 different packages. So you have the mypod client, mypod Flutter, and mypod server. In the mypod server package, you place your models and your endpoints and all server code. The mypod client, typically you don't really need to touch that. It contains generated code that is then imported in the Flutter directory. So you typically work with your Flutter app, and which is in the mypod Flutter directory or package, and the mypod server. The reason we made the client separate is that maybe there's a possibility you may want to have more than one Flutter app that connects to the same server. Then it's really nice to have that separate. Or maybe you don't want to build a Flutter app at all. Maybe you're making a CLI, or it just gives it a little bit more flexibility. To start your server, you go into the server directory, and first you start Docker with Docker Compose up, and then you just start it with the dart bin /main.dart. And first time you start it, you should also apply migrations, which will set up the default set of tables for Serverpod. So Serverpod handles a few database tables for doing things like the future calls or logging and stuff like that. So that's why you have to apply the migrations the first time you run it. We're going to have a quick look also on how you work with the database and can do those migrations yourself. On the Flutter side, you can just go into the Flutter directory and do Flutter run, and then Serverpod creates a very basic example app. It's basically a hello world app. You can send a string to the server, and it sends back hello, whatever string you sent in. So right off the bat, everything is just connected and ready to go. So it's very easy to get started. We're going to look first a little bit on the structure of your server project. And there's really just 3 directories. There's quite a few directories. Like when you build your first Flutter app, you can see there's like a lot of directories and files in there. It's the same with Serverpod, but it's really just 3 directories you need to pay attention to in the beginning. The first is the configuration directory, and here you have configuration files for your development, staging, and production environment, and you can set like the ports the server will listen to and stuff like that. There's also a passwords file here, which is set up with everything to make local development work, but you may change that later in there. And then you have the endpoints directory. This is where you will place your endpoints. Here's just like the example endpoint that comes with Serverpod. And finally, we also have a models directory. And this is where you place your data models. So those are basically the 3 different directories you need to keep a little bit of track of. All right, so anytime you change something in Serverpod, like in the models directory or in your endpoints, you need to run the Serverpod generate command. That will analyze your server and build both the code required in the server, the generated code for the server, but also the client code. So whenever you add a new method, or if you add a new model, or if you change any of your models or endpoints, then you just run Serverpod generate and everything will be up to date again. You can also start Serverpod generate with a -- watch flag, and then it will continuously monitor your changes and regenerate the code. Can be a good little trick. Next, let's look at how we build these endpoints. There are a few things you need to keep in mind while doing that. First, you need to place the endpoints in the endpoints directory, in the libsource endpoints directory of the server. Next, your endpoint needs to extend the endpoint class. And the methods you add to your endpoint needs to return a typed future. And the types you can use are all sort of basic Dart types, booleans, doubles, date time, even byte data if you want to send binary data will work. But you can also send models that you create or serializable objects. It works with models you build in Freest, for instance, too, if you want to use some other serialization that it's provided by Serverpod. And the first parameter in your method must be a session object. The session object keeps information about the call that's being made to the server, but also gives you access to logging and the logging and database and messaging between servers, stuff like this. All right, so this is an example of an endpoint. This is the example 1 with a hello method. So as you can see, we extend the endpoint class here. We call it example endpoint, and it returns a future string. The method name is hello, and the first parameter is the session object, and then we can pass in any number of parameters. So here we just have a string that's a name, but this can be named parameters or optional parameters. Everything works just as you would expect. And then we just return hello, whatever that is. And after we add this, we run Serverpod generate, and from our app, we can just call it through the client object. So the client object is automatically created in your example project. It's just a one-liner to create your client, and then you can access the example endpoint here, and then the hello method. And it returns a future with the results. So this is really all there is to it. You can add any type of methods this way. So pretty cool.
Client class, is it like some kind of generated code? Or?
Yes, this is all generated code for you. So under the hood, it builds REST API. So it's all like a well-formed REST API. Next, we're going to look at how you build your models and serialize your data with Serverpod. And when you choose to do the models in easy-to-read YAML files, and the reason we picked YAML is that allows us to, in the future, right now we just generate Dart code, but in the future we'll be able to generate code for JavaScript or Kotlin or any other language. So that gives a whole other level of flexibility. You place the models in your models directory, and whenever you do changes, remember to run Serverpod generate, and they will be all created. So this is an example of a simple model with a company. You first define the class and the name of the class, and then the fields. So here we have a name that is a string, found the date, a date time. It works with nullability, and you can even have lists or maps. They just need to be typed. We support all the types supported by Serverpod. So here we have another model that's employee, for instance, so we can return a list of employees. And from Dart, you use it just like you would expect. You just create your company class and add Serverpod. Employees is me. I probably should update this code because we're now actually 7 full-time employees at Serverpod working on advancing the framework and Dart on the server. And then obviously you can get access to any of the properties just like you would expect. So very easy to read Dart code as well. But what is really cool with this is that you can map these models to the database. So you do that by just adding a key that's called table. So here we have the company table, and that's really all you need to do. But when you add tables to a relational database, you actually need to create the tables before you can insert data in them. And we do that with something called a database migration. And the database migration just takes the sort of structure of the database from one state to another. So the way that works in Serverpod, whenever you've done these changes, you just do a Serverpod create migration, and then we'll create a database migration, which is basically a set of SQL queries that will advance your database structure from one version to the next. And to apply these, you just run your server, and you do the apply migrations command or flag. Here we also add a maintenance role. If you run Serverpod in maintenance mode, it will actually not start a server, but it just runs any tasks you may have. So here it's like for applying migrations. It will apply the migrations and then quit. So that can be useful if you, for instance, run Serverpod from concurrent deployments and stuff like that. All right, so that's how you add new tables. Let's have a look at how you actually add things to your database and retrieve the data. In Serverpod, we generate types and methods for all the models that you add. So for the company, first here at the beginning, we must just create a new company class, and then the company has a static field called DB, which gives you access to a number of database methods for inserting, deleting, and finding things in the database. So we're using the insert row. We also have support for inserting a batch of rows if you want to do a bigger data insertion, for instance. And just pass in the company and the session, and it will return a new copy of your inserted row that also has an ID field set, because every database row in Serverpod or model connected to the database has an ID property which uniquely identifies that row in the database. So that is to make, for instance, updates work correctly and stuff like that. Can be good to know. All right, next, let's look at how we find the stuff in the database. In this example, we just looking up a table by its ID. So there's a find by ID. If we have that ID number, it's very easy to pull it out. If we want to do a little bit more advanced search, you can use a find first row or a the find method. The find first row will return just the first row it finds that matches your query. And the query you pass into the where clause, and it's actually a query builder. So it will take a table description that describes your database table, and then you return the actual query. And the reason we're doing this is that allows us to do everything in a type-safe way, so that database, the T here, will have knowledge about all the columns that you have in that particular, or basically the fields in that object. So we can just do t.name, because we know it's The company has a name, and it equals my company in this case. So that example will return the first row in our database where the name of the company equals my company. But obviously you can build way more advanced queries with this. And the really neat thing is it's all Dart first and type safe. So you get like help from the editor with autocomplete and all that stuff. I want to give you a few more tips and tricks on how to work with models, because not all models must necessarily be classes. You can also make exceptions. I guess technically an exception is a class too, but this allows you to make serializable exceptions. That means that if you throw this exception on the server, in a method in your server, you can catch it in the client, which is pretty neat. It's a great way of handling errors. That really simplifies the flow of your code. I'm sure you have used this in Flutter, and sometimes it's super convenient to be able to just throw an exception if something goes wrong, and then you can check that exception and see what actually happened. So you can do that across sort of the gap between the client and server, which is really, really nice. Of course, if you throw any other exception that is not serializable, that will stay in the server, so you will never leak any information that you don't want to leak. We also have support for enums. They work just as you would expect. You just specify the values. Pretty easy. And you can also do documentation, code documentation on the models. We use the triple hashes, which will then be translated to Dart docs triple slashes in the generated code. So your documentation of the models won't get lost in the code generation. They will stay all the way, even on your client and on the server. So that's also pretty neat. Next, I want to talk about the feature that we added in Serverpod 2.1 just a few weeks ago. We've been working on this for, probably almost 4 or 5 months. It turned out to be a little bit more tricky to do than we anticipated, but it's such a great feature. We had a system for doing real-time communication before, but this just takes it to another level. So this is an example of we're back in the example endpoint. Instead of returning a future of something, you can now return a stream of something. So here we have a stream of integers, and we have a method that we call countdown. Takes the session objects as usual, and then instead of just using async, we can use async star. And that allows us to yield values, so we can basically return more than one value from our method. So here we're counting down from 10 to 1 and return the values and have a 1 second delay between every value that we return. So that makes doing real-time communication very, very simple. You can return not just integers, but all types supported by Serverpod. Or you can even leave out the type, and it supports dynamic types too, so you can have multiple models that you send back through your stream. Very soon we'll also have support for inheritance and sealed classes, which will be super nice to use together with this. So that's coming soon. So let's look at how that looks on the client side. No, we built it's all our own stuff. So Serverpod is somewhat similar to gRPC, but we support a much richer feature set. There's like many things that we couldn't do with gRPC. So on the client side, you just get a client, the example endpoint, and the countdown method, and that will give us a stream. And then we can just use the await for construct to listen to that stream and get each value as they come. In this example, we're just printing them to the console, but you can do obviously whatever you want with that data. So that's how you do real-time communication with Serverpod. It's, as you can see, super easy to get started with. Next, I want to talk about deploying your server, because that's typically also a pretty big pain point for many users we've found. We made Terraform scripts for AWS and Google Cloud and have great guides for doing that. So it's not that hard, but you still have to manage your infrastructure. Therefore, we're building a Serverpod cloud. It's currently in beta, so if you want to try it out, you can find us on social media, and there's links there for signing up to the beta. I'm just going to give a quick demo of what it actually looks like right now. So you can just create a new project. We have a new scloud command. So you create a project and give it a project ID, and then you just do the scloud deploy and your project ID, and that will set everything up for you, and it's also super fast. So this is just the demo page of that working. So that will come very soon, hopefully, when we get it out of beta to everyone. Yeah, so if you want to learn more about this, you can find Serverpod at serverpod.dev, or you can follow me on social media, Viktor Lidholt, or at serverpod.dev. If you have any more questions, you can find me. We have a booth here outside, so feel free to come and chat with me. I'm happy to answer any questions.